Hello and welcome back, all of you. In this lecture, we are going to discuss about concept of under reinforced sections. In previous lecture, we have seen the concept of balanced sections, in which that we have considered that the balanced section is a section in which the maximum stresses in steel and concrete reaches at the same time. Or in other words, we can say that the materials, that is concrete as well as steel, will be strained to their fullest allowable values at the same time. And these allowable values are epsilon Cu, that is the ultimate compressive strain in outermost compression fiber of concrete, which which value of which is 0.0035, and ultimate tensile strain in the tensile steel, that is epsilon CSU. This value will be equals to 0.87 Fy upon Es plus 0.002. So these values reaches at the same time. So that section will be termed as a balanced section. And again, we have seen that the whatever strain variation is there, the strain variation will be linear throughout the section. The depth of neutral axis is called as a limiting depth of neutral axis, which is denoted by XU limiting. This we have seen in the last lecture. So today we are going to see what is the meaning of under reinforced sections. So by the name of this section itself, we'll get a little bit idea that what will be the under reinforced section. So just meaning or just the name indicates that if we compare this section with the balance section, here the section is under reinforced, or we can say that in this under reinforced section is the section in which the steel is less than the required for a balanced section. Steel is less than required for a balanced section means that whatever amount of steel is required for a balanced section, if we provide a little bit lower amount than that balanced section, then that particular section will be called as a under reinforced section. So let us see that there is a beam which is having an overall depth D, overall width B, and the steel is provided here is comparatively in less amount as compared to the steel what we have seen in the previous session, that is for the balance section. Okay, so amount of steel provided here is less than that what we required for a balance section, so that's why this section is called as a under reinforced section. Now what will be the result of this less steel provided? It ultimately results that whenever the beam is subjected to external loading, the whatever stresses which are going to develop in the both materials, that is concrete as well as steel, these stresses will not be equal, because as we have seen in the last part or last session, that when the stresses in both materials, that is steel as well as concrete, reaches to their maximum values or maximum limits at the same time, then that particular section is called as a balance section. So at that time, that whatever amount of steel that we have provided, that will produce the equal amount of stress or equal amount of strain as which is produced in the concrete. But in this case, that is in case of under reinforced section, the amount of steel provided is less than that of the balance section. So ultimately, the result of this is that whatever reinforcement that we are going to provide, that reinforcement is stressed to its maximum permissible stresses, while the concrete is stressed below the permissible stresses. What happens? That due to the amount of steel is less, whatever amount of steel available here, that amount of steel is less as compared to the balance section. So Whenever the beam is subjected to external loading, whatever stresses are going to develop in this concrete, which is in compression above the neutral axis, and the tension which is going to develop at the bottom part of the neutral axis, now all tensions should be carried by the reinforcement, and the whatever stresses which are going to develop in this portion or develop in the steel, those stresses are reaches to its permissible value before the permissible values in concrete. Or ultimately we can say that whatever amount of strain which is given in concrete, that is epsilon cu, and the amount of strain in steel, that is epsilon su, this epsilon su is equals to 0.87 Fy upon Es plus 0.0025. So the strain in tensile steel will reaches to its yield strain or yield value earlier than the compressive strain in concrete. It means that the value of epsilon su will be reaches to its ultimate value before concrete. It means that whatever amount of steel that we have provided, that amount of steel is less, and which results in excessive strain in the steel beyond the permissible value, that is 0.87 Fy upon Es plus 0.002. So that whatever steel is provided will that steel will strains beyond its permissible value. It means that there will be a considerable amount of cracks will get formed because that steel is going to extend uh, rigorously, or that elongation or the ultimate strain in steel will be more than the strain in concrete. So that's why it results into excessive elongation of the steel. Okay. And due to this excessive elongation of steel, that whatever tensile stresses are going to develop, those tensile stresses may be transferred to the concrete, and due to which the excessive cracks in concrete will get formed. So, due to this excessive cracking, the deflection of that beam is also going to increase, and this deflection will serve as a warning to the users so that the users can evacuate the building. Okay. So, the less amount of steel will result into excessive deflections or deformation of the beams, and crack formations is also going to happen there, so which gives the indication about that the beam may fail if the loading applied on that beam is continuous, so that the users can evacuate the building. And that is the reason why IS 456 2000 specifies that the maximum strain in tension steel shall not be less than 0.87 Fy upon Es plus 0.002 at the time of failure. Because if the strain in steel is more than this value, then there will be excessive deformation, excessive crack formation will be there, and which gives some idea about the possibility of failure of that structure, so that the users can evacuate that building to avoid the possibilities of accidents which may result into loss of life. So to avoid that, I specify that the maximum tensile strain in steel shall not be less than 0.87 Fy upon Es plus 0.002. In other words, we can say that the IS code prefers design of under reinforced section. So we can say that the IS code recommends that whatever sections that we are going to design, those sections should be under reinforced section, or at the most it can be a balanced section. Okay. But if the section is under reinforced section, then it will be much better because it will give a very earlier idea about the possible failure of the structure, so that we can avoid the loss of life. The limiting condition here in case of under-reinforced section is that the actual depth of neutral axis will be less than the limiting depth of neutral axis. That is, this is the limiting depth of neutral axis, XU limiting, what we get in whenever the section is a balanced section. But now, as you can observe here, as the amount of steel provided is less here, so the strain in steel will be more, and comparatively at the time of failure, the strain in concrete will be less. So that's why this neutral axis will get shifted at this point. Okay, so we can say that this value will be the actual depth of neutral axis, that is XU. So if you compare this XU with XU limiting, you will find that the value of XU limiting will be more than XU. So that is the limiting condition here, what we have discussed, that the limiting condition for under reinforced section is XU less than XU limiting, that is actual depth will be less than limiting depth of neutral axis. Okay. So this is about the under reinforced sections. We'll stop here with this concept, that is under reinforced section. In next lecture, we'll discuss about the over reinforced sections. Thank you. If you like this video, then don't forget to click on like button, and also don't forget to subscribe this channel so that you'll get the various information about the videos which I am going to upload on this channel. Also, do not forget to share this video so that your friends will get benefit of it. Thank you.